Welcome to Episode 2 of our high school physics series. Today we're going to look at motion in one dimension, so this is one of the first topics that you learn about when you start doing physics. So let's get into it. So if you haven't seen the first video, we are working through the whole high school physics curriculum episode by episode. And you can see the structure of each video in the description. Okay, so what do we mean by motion? Well, motion is just the change in position of an object over time. Now, because it's a change, you need a reference point to describe it. This tree is not moving. The car is moving along the road, and the ball is also moving as it falls from the building. There are different types of motion, such as translational motion, where an object moves in a straight line like the train, or rotational motion, where an object spins like a wheel. We are going to focus here on translational motion and in one dimension, so basically a straight line. You will learn later about motion in two dimensions, which is a bit more complex. Okay, so we have talked about distance before, but here we want to define how distance and displacement are different. So distance is how much ground an object has covered during its motion, whereas displacement is the change in position with direction. So let's imagine you walk 4m forward, then 2 m back. The distance is the total length of the path traveled, which is 6 m, but the displacement is only 2 meters forward because that is the change in position. Now notice that distance is a scalar quantity, which means it doesn't have a direction associated with it, but displacement is a vector quantity, which does have a direction. Now we can use these ideas to find speed and velocity. So remember, speed is how fast something is moving, and velocity is how fast something is moving in a specific direction. Let's imagine we are walking the same distance again, but this time we walk 4 meters forward and then 2 meters back. The average speed is the total distance divided by the total time taken. So 6 meters divided by 1 second equals 6 MOS. But what is the velocity? So the displacement was 2 meters forward. So the average velocity is the displacement divided by the time taken. So 2 min-y per 1s or y to m1 So notice that speed and velocity are different quantities. Speed is a scalar and velocity is a vector. Now we know the average speed and average velocity, but we also want to talk about instantaneous speed and velocity. So instantaneous speed is the speed of an object at a single moment in time. And we can find the instantaneous velocity by finding the slope of the displacement time graph at a single point. You will learn later about calculus and derivatives, but for now, we are just going to use the basic definitions. So we can say the instantaneous velocity is the limit of the average velocity as the time interval approaches 0. The average speed is calculated by dividing the total distance traveled by the total time taken. The average velocity is calculated by dividing the total displacement by the total time taken. In the example above, the average speed is 6 meters, but the average velocity is 2 meters forward. Let's look at this motion graph. As always, we have time on the horizontal axis and displacement on the vertical axis. So the slope of the displacement time graph gives us the instantaneous velocity. If the velocity is constant, then the graph is a straight line because the slope is constant. If the velocity is changing, then the graph is a curve. Also notice that the area under the velocity time graph gives us the displacement. So if we calculate the area of each of these trapezia, we get a displacement of 20 meters. Okay, so far so good. Now let's look at acceleration. So acceleration is the rate of change of velocity. It is the change in velocity divided by the time taken for that change to occur. We can write this as a formula a sexto v u sexto t, where a is acceleration, v is final velocity, u is initial velocity, and t is the time taken. So if the acceleration is positive, then the object is speeding up, and if the acceleration is negative, then the object is slowing down. Now, sometimes you might hear this called a deceleration, but be careful because technically deceleration is just the name given to negative acceleration. So when something slows down, it has negative acceleration. Now let's look at some examples. So in this first example, the velocity changes from 4 meters per second to 12 meters per second in 3 seconds. So if we plug these values into our equation, we get a Frers 12.4, 3 Frers 4, 3 from meter 1.33 m all s2. Notice that the units for acceleration are meters per second squared, or ms2. Now in this next example, the velocity changes from 12 ms to 4 ms in 3 seconds. So if we plug these values into our equation, we get a Pwahast 412.3, Hast 83, Hast 2.7 ms2. Notice that the acceleration is negative, which means the object is slowing down. Now we have 3 equations of motion that we can use for uniformly accelerated motion in 1D. So you just need to memorize these. So the first equation is v or charge u plus at. The second equation is s charge ut plus 1 pro 2at2, and the third equation is v2 charge u2 plus 2as. And these are valid only for 1D motion with uniform acceleration. Now you will need to know how to use these equations in your physics exams. Okay, let's look at an example. So a car accelerates uniformly from rest to a speed of 20 ms in 4 seconds. We want to find the acceleration, so first we need to identify the knowns and the unknown. So we know the initial velocity, the final velocity, and the time taken. And we want to find the acceleration. So looking at our 3 equations, we see that the acceleration is in the numerator of the second equation. So this is the best equation to use. So if we rearrange this equation to solve for acceleration, we get a 2v/ut. Now you might think this is easy, but many students make mistakes with signs and numbers. So pay attention to the units and the signs of the numbers. So if you get a negative answer, this means the object is slowing down. And if you get a positive answer, this means the object is speeding up. And don't forget the units. They should match the units of the known values. Now we've been talking about uniformly accelerated motion, but there's another type of motion called free fall motion. So an object is said to be in free fall when the only force acting on it is gravity. So in this situation, the acceleration is equal to the acceleration due to gravity, g, and the value of g is approximately 9.8 meters per second squared. We take it to be 10 ms2, and it's positive if the object is accelerating downwards and negative if the object is accelerating upwards. So the acceleration due to gravity is always acting towards the center of the Earth. You can neglect air resistance unless otherwise stated in the question. So we can use the equations of motion, but instead of acceleration, we use g. Okay, so here's a quiz question for you. A car accelerates from 0 to 20 ms in 4 seconds. What is its acceleration? A. 2.5 ms2, B. 5 ms2, C. 10 ms2, or D. 80 millimeters s2. Pause the video here if you want to make a guess. So the correct answer is C. 10 ms2. Here's how to work it out. So we know the initial velocity, the final velocity, and the time taken, and we want to find the acceleration. So the best equation to use is s ut plus 1/2at2. We can rearrange this equation to solve for acceleration. Ida 2v ut. Okay, so that's a summary of episode 2. So in this episode, we learned that motion is the change in position of an object over time. We defined key terms such as displacement, velocity, and acceleration. We looked at how to find speed and velocity from displacement time and velocity time graphs. And we also learned 3 equations of motion that we can use for uniformly accelerated motion in 1DF. We also talked about free fall motion, where the only force acting on the object is the force of gravity. Okay, so that's it for this video. If you liked this video, please hit the like button, and if you haven't subscribed yet, please do so. Thanks for watching.